Good morning. For this assignment, you will be applying the Pythagorean theorem as well as special right triangles, which is um, actually one form of the Pythagorean theorem. So I'm going to work through this first problem as an application. First, just to go over the assignment, the first three questions, you're simply going to use um, the Pythagorean theorem to find the missing value, right? The C value is always across from the right angle because that's the hypotenuse. It asks, in addition to finding the missing side, the x value, they also ask if it's a triple. If it's a Pythagorean triple, then then your answer will be a whole number. So that's how you can tell if it's a Pythagorean triple. If it's not a whole number, then it's not. Okay, the rest of the assignment use our special right triangles. Remember, we only have two types. There's the 45, 45, 90 special right triangle. Then there's the 30, 60, 90 special right triangle. So there's only two types. And the ratios are in the notes. So you're going to use that to find the areas of these two triangles. Then here's another application. Again, these both apply special right triangles. You have to figure out what type of triangle it is and then apply to find the missing values. And this is sort of an application because it's about, this piece of jewelry and you have to find like the height of it. Okay. But one application definitely is finding the area of these triangles or the dimensions of these triangles. Now notice they are equilateral triangles, not right triangles. However, we'll see that we'll use our special right triangles here. So it says area of a window. A hexagonal window consists of 6 congruent panes of glass. Each pane is an equilateral triangle. Find the area of the entire window. Okay, since it's an equilateral triangle, we can actually divide it in half like this. Look, if we divide it in half like this, let's see if I can draw this directly down from the top here. That's close enough. Notice it makes a right triangle, okay? This right triangle will help us find the height here. Okay, but first let's zoom. Okay, so let's zoom in actually on this triangle a bit. So let's say this is that triangle, okay? And actually, I wanted to make this line red to make it stand out. So there. Then I draw another line from, again, the top of the triangle to the bottom. Okay, and notice that makes a right triangle right here. So let's see, let's figure out, first of all, the base of this entire equilateral triangle. Well, 2 of them is 8 feet, so one of them is 4 feet, okay? One of them would be 4 feet. So then half of that would be 2 feet. So the height of this is 2. And this is our right triangle. This is a 30, since this is 60 degrees, and this is 30 degrees, we know the ratio of these sides. Now to find, remember that the hypotenuse is twice the amount, 2 times 2 is 4. But the value we actually want to know is the height of this triangle. The height of the triangle is 2 square root of 3, right? Okay. So all these triangles are congruent. So all these triangles have a height of 2 root 3. Okay, so let's find the area of this triangle. Remember, the area of the triangle, equilateral triangle, is the base, 1/2 base times height. So it's 1/2 times the base, which is 4. Just put 4 there. And the height, which is 2 root 3. Okay, let's simplify that. Okay, well, let's see, 1/2 and 2, those cancel out, so we're left with 4 root 3 square feet. Okay, that's one of the triangles. So the area of the hexagon, I'll put H here for hexagon, is 6 times, right? 1, 2, 3, 4, 5, 6, the area of the triangle, right? You use a subscript sometimes, subscript, okay? And then we say, okay, 6 times this number, 4 root 3. So it's 24 root 3 square feet. So that's the area of the entire hexagon. Now notice I keep the root 3 there because that's an exact answer. You could use a calculator to estimate the answer, but that is the area. Notice how we could find this only because we knew special right triangles, right? Whenever you divide an equilateral triangle in half with its altitude like this, you always get a 30, 60, 90 triangle. You can then, if you know the base length, you can divide it in half. Here it's 2, is half the base length. That's this part of the triangle. The shorter leg is 2. So the longer leg is 2 root 3, which is the height of the triangle. Now that we have the height, we can find the area, okay? So this is one very common application of special right triangles. And you can see how you could apply this similarly to the rest of the assignment. All right, well, just try your best on that. Again, please ask if you have any questions. You can attend tutoring or ask during your in-person day. Or, of course, always message me on the Google Classroom. All right, very good. Well, just do your best with that, and I will talk to you next time. All right, have a good rest of your day.